This lesson is vectors. So here we have an example. Point P, point Q. So P, point P, point Q. So x sub 1, y1, x2, y2. And we're trying to find the position vector. Position vector is a vector that will always at 0 where the center is and then pointing out. One more time. Position vector is always at 0. Right here, here is 0, 0, the origin pointing out. That's why it's called position vector. Okay, so point P, point Q. Again, what I have here is just approximation. It is not an exact graph. Okay, so point P will be here, point Q would be here. Okay, and the direction is going down from left down right. Okay, now we want to find the position vector, same vector right here where I am circling the same vector, but at the origin pointing out. Okay, so again, position vector is where it will always be at the 0, the origin pointing out. And to get that position vector, here's the formula: x2 minus x1, y2 minus y1. So 6 minus, but x1 is also negative, make sure you put in parentheses. 2, y2 is 2, minus, and y1 is 4. And just basic order of operation, negative and negative gives me plus, so 6 plus 1 gives me 7, 2 minus 4 is negative 2. So this is the vector right here. This is the vector right here in position vector, which is right here at the origin pointing out. Okay, so this vector is the same as this vector. The only difference is that this vector will always be at 0, 0, the origin pointing out. Okay, so that's why it's called position vector, because it is always at the origin pointing out. Okay, next example, we want to find the magnitude or the length of a vector. So we want to find the length, and magnitude is just a fancy way of saying the length of the vector. Okay, and this is how we represent the magnitude of a vector with double absolute value. Okay, double absolute value on left and on the right. Okay, so here I have a vector 3i minus 4j. Okay, so we want to find the magnitude of that, or the length. Okay, and how do I represent the magnitude of a vector? Using double absolute value. Make sure you write these absolute value a little bit longer. Don't write it so small that it looks like 11v11. Okay, so make sure the absolute value are longer. Okay, so it's very easy. You will square the x, or right here, or the I. So just ignore the letter I, ignore the letter j, just focus on the number. So square the 3, always plus, square the negative 4. Okay, so 3 squared will gives me 9, negative 4 squared will be 16, 9 plus 16 is 25. Don't forget to square root, always square root, and that gives me 5. So this vector right here where I am circling has a length of 5. Okay, all right, so again, magnitude is a fancy ways of saying the length. Every vector has a direction, has an angle, and the length of the vector. Okay, so this vector right here where I'm circling has a length of 5. Okay, next, so let me zoom out this one. Okay, oh, I forgot to show you the graph. So here's the graph. Here's the vector 3i, 4j. So pretend that this is the x and this is the y. So 3x, so 3 go out this way. Since y is negative 4, so go down 4. So there is my vector, negative 3, 4. And there's my magnitude or length, which is 5. Okay, right, so that's where the graph is. So let me zoom this out so you can see the entire example of this page. Okay, All right, now let's go on to the next page. Now we want to find the direction, the unit vector. Okay, find a unit vector in the same direction as this vector. So here's my graph. Just give you preview what it looks like. 4i minus 3j is the one in blue. But we want to find the unit vector in the same direction. So what is a unit vector? Just think of it as being shrink down. Okay, it's being shrink down, okay, to unit. What is unit? 1. The word unit means 1. Okay, so this vector is shrink down to 1, or better way to call it unit vector. Okay, the word unit means it is 1. Okay, so first thing we need to do is find the length or magnitude of this vector. Find the length or magnitude of this vector. So 4 squared is -3 squared. So 16, 9, 25 square root 5. Okay, so that's the first thing we need to do is find the length of the vector. Okay, next we're going to use the original vector divided by the magnitude of its vector. Okay, so here's the formula. We're going to take the original vector divided by the magnitude of its vector. Okay, so here's the original vector, 4i minus 3j, divided by the length of its, okay, vector. Okay, so just divide it. So you can separate them out. So 4i divided by 5 minus 3j divided by 5. So this is the unit vector, okay, that is in the same direction to the original vector. Okay, so one more time. This is the unit vector in the same direction as the original vector. So the blue line is the original vector. The one in red is the unit vector. Again, unit vector, just think of it is being take the original vector and shrink it down to 1 unit. Okay, so shrink it down. That's why it's called unit vector. Okay, so the blue line is the original vector. The red line is the answer that we need. Okay, again, just think of unit vector is just shrinking the original vector down to 1 unit. Okay, shrink it down to a unit. Okay, all right, next we are trying to find the angle of a vector. Okay, so given a length, given a degree, giving a length of a vector, giving a degree. So using this formula, here's my length, plug it in. What is my angle? 60 degree. What is my angle? 60 degree. Okay, and then use your chart. What is 60 degree? Cos 60 degree, which is 1/2. What is sine 60? Square root 3/2. Okay, now distribute the 5 to both of these. So 5 times 1/2, just 5/2. 5 times square root 3/2 is just 5 square root 3/2. Okay, so this is the vector that has the length of 5 with a degree of 60 degrees. Okay, so again, this is the answer that we're looking for. The vector that has a length or magnitude of 5 and a degree of 60 degrees. Now on the graph, this is what it looks like. So this is my x, 5/2. This is my y, 5 square root 3/2 with the length of 5 and the degree is 60 degrees. Okay, so this is what it looks like on the graph. Again, what I have here on the graph is just approximation, not accurate. Okay, so let me zoom out so you can see the whole thing for this page. Okay, all right, so we got one more page. Is to find the angle. Okay, is to find the angle. So here the directions of angle. So here's a vector. 3i, 2y. And to find the angle, we always use tangent. One more time. To find the angle, we always use tangent. And you know that tangent is y over x. So y is 3. Y is 2. X will be 3. Okay, so one more time. To find the angle, we use tangent. And we know that tangent is y over x. So y is 2. X is 3. So 2/3. Okay, bring tangent over will be the inverse of tangent. 2/3, put that in your calculator, comes out to be 33.6874. Let's just round it to 33.69 degrees. Okay, so this vector has an angle of 33.69 degrees. Okay, so again, vector, let me go back to this page, the second page. Vector has a direction, has a length, and has an angle. Okay, so again, vector has a direction, has a length. Okay, so vector has a direction, has a length, and has a degree. Okay, all right, and position vector is always at the origin. One more time, position vector is always at the origin. Okay, so this is the lesson for vector. Okay, so let me go back to this last example. Okay, all right.